Hello everyone. I hope that you guys are all doing well. I'm missing you guys a lot. Today we are going to talk about adding and subtracting rational expressions. So just to recap, so far we've talked about simplifying rational expressions, kind of the same as reducing fractions. We've talked about multiplying and dividing rational expressions, kind of the same as multiplying and dividing fractions. And today we are going to talk about how to add and subtract these things. So just like we did with the other two lessons that we went through, I'd like to start this one by looking at how do we do this kind of stuff with numbers. Okay, so let's have something like 2/4, whoops, there we go, whoops, 2/4 plus 1/4. Okay, when you have 2/4 plus 1/4, well, when we have denominators that are the same, we can just add the numerators. We got 3/4. Okay, so that's pretty straightforward. If we have something like this, 3/5 plus 1/3. Okay, well here we've got a bit of a problem because these two denominators are different. So we have to come up with a least common denominator. And in this case, the least common denominator happens to be 15. So to basically get that LCD, or least common denominator, of 15, how do we achieve that? Well, we can achieve that by writing each of these original fractions as equivalent fractions using that denominator of 15. Now, how do I do that? Well, to get 15 in this denominator, I need to multiply it by 3. But I can't multiply the denominator by 3 without multiplying the numerator by 3, because then I'm changing the value of the fraction. If I multiply it by 3/3, all I'm doing is multiplying that thing by 1. Now this one, 1/3, the factor that's missing in the denominator is 5. So I need to multiply that by 5 in the denominator. But if I multiply that by 5 in the denominator without multiplying it by 5 in the numerator as well, then I also change the value of the fraction. So I have to multiply it by 5/5. Okay, now if I rewrite out the, whoops, what am I doing here? The two fractions that I have, I hope my pen works. I'm going to have 9 over, nope, I didn't want to do that. Hold on. There we go. 9/15 plus 5/15. Those are my equivalent fractions. And now, since the denominators are the same, I can add the numerators, and that gives me 14/15. Okay, so this is stuff you guys have been doing for a long time. Now we'll do one more, and then we're going to actually do one more and compare to the one we just did. So let's do 7/8 minus 5/12. Okay, now the least common denominator, or least common multiple, because that's what a least common denominator is, it's the least common multiple of 8 and 12. Between 8 and 12 is 24, right? If you think multiples of 8, 8, 16, 24, 32. Multiples of 12 would be 12, 24, 36. The one that's common to both is 24. So to get a common denominator of 24, I need to multiply this first fraction by 3/3, because 3 times 8 is 24, and this one by 2/2. Okay, so let's see what that gives us. I'm going to get 3 times 7 is 21/24, minus 5 times 2 is 14/24, and that gives me 7/24. Okay, so there we go. I've subtracted two fractions, but I want to ask an important question, and I want you to think about this. In this example over here, the LCD was 3 times 5. It was the product of the two original denominators, and that was not the case for our second example. The LCD was not 8 times 12. It wasn't, what is 8 times 12? 8 times 10 is 80, so 96. It wasn't 96, okay? So we have to figure out, how are these two things different? And what it really comes down to is looking at the prime factorization of 8 and looking at the prime factorization of 12. And the reason why I bring this up is when we are finding least common denominators with rational expressions, we have to look at our least common denominators in factored form, or our denominators rather in factored form, and figure out the least common denominator based on the factored form of each denominator. Okay, and so that's why this is going to become important. So if I look at 8 and I break that down, that's 2 times 4 and then 2 times 2. 8 is, 2 times 2 times 2. Okay, 12 is 2 times 6 and then 2 times 3. So 12 is 2 times 2 times 3. Okay, now this was something that you looked at in 10C, but I know it's been a while, so we'll just recap. To get a least common multiple, you have to have every single prime present from each prime factorization. But if they share primes, you don't have to repeat them. Okay, so I have to have 3 2s because that's what I see from the 8. Okay, I have to have at least those. But then I don't have to repeat 2 of them. I don't have to repeat these 2 for the 12, right? Because I've already got 2 in there. So if I start writing out my LCD, I know I have to have these 3. I've got to have 2 times 2 times 2 because I have to be able to see the factor of 8 in my LCD, okay? But now when I'm moving on to 12, I need to be able to see 2 times 2 times 3. Well, I've already got 2 2s in there. So I just need to add a 3. Now if I look at this part, there's my 8. And if I look at this part, there's my 12. So I can actually use these 2 shared primes when I'm looking at both the 8 and the 12. And that's why the LCD was not 8 times 12. It's because 8 and 12 actually share primes in their prime factorization. Now that's not true for 3 times 5 or 3 and 5, and that's why when we were looking at denominators in 3 and 5, we had to actually multiply those 2 values together to get the LCD. Okay, so here the LCD is 2 times 2 is 4, times 2 is 8, times 3 is 24. Okay, now with numbers, we typically don't think about this sort of thing, particularly when we're working with smaller numbers, because it's really easy to do that sort of thing in our head. But we are going to have to start thinking about least common denominators when we start adding and subtracting rational expressions from the factored form of the denominator. Okay, so just wanted to go through that little introduction. I hope you guys aren't hearing, yesterday you had some background noise from my dog. Today there may be some background noise from my son. He's popping in and out of here, so hopefully he won't disturb us too much. But I'm just giving you that little heads up, just in case. Okay, now let's go on to the topic of the day. Where are we? Nope, this is not us. This is calculus. Let's go to 20-1. Here we are. All right, and here's where we left off yesterday. Perfect. Okay, so how are we going to do these? Well, step 1 and step 2. I'm going to talk about step 1 and step 3 because we could do step 1 and step 3. We can kind of interchange step 1 and step 2 here. That's listed. And step 1 and step 3 are something that we have to do with anything that's dealing with rational expressions. Number 1, factor. Number 2, non-permissibles. Okay, so factor and non-permissibles are, it's essential that you do factoring and non-permissibles for any time that you deal with rational expressions. Okay, now we'll talk about LCD, finding an LCD in a moment, but you can actually interchange these two steps. So I typically do non-permissibles when I'm dealing with my factoring, or at the same time as my LCD. Okay. All right, so let's look at this one. M over n minus m plus 1 over n. Okay, well, here we're subtracting two rational expressions rather, that already have a common denominator. So what we can do is just go ahead and add or subtract the numerators. Now, what you have to be really careful about with subtraction is that this negative sign applies to the entire numerator. So don't go too fast. Take an extra step. Okay. Now, because I didn't have to deal with factoring, I actually missed the fact that I haven't dealt with this yet, which is my non-permissibles. Okay. So here, the only variable that I have in the denominator is n. So my non-permissible is that n cannot equal 0. Okay. Now, I can now write this as a single rational expression, and it would look like this. The denominator would be n, and the numerator would be m minus m plus 1. Okay, now I know that seems like it's not a big deal, and we shouldn't have to write that line out, but you'd be surprised how many people make the careless mistake of not subtracting the 1 as well. Okay, so with subtraction, I highly recommend that you take that extra step of actually writing this all on a single line so that you can distribute that negative sign. Okay, so I'm running out of room here, so I'm just going to move up here. So that's going to be m minus 1 over n, which is negative 1 over n. Okay, so that is the simplified rational expression once you have subtracted. Okay, here we also have a common denominator of 4m minus 3. Okay, so again, we can just go ahead and, in this case, subtract. Now, before we do that, though, of course, we should deal with our non-permissibles. Here, 4m minus 3 cannot equal 0, which means 4m cannot equal 3, which means m cannot equal 3 over 4. Okay, and I'm showing the process of how to find this non-permissible, but I know many of you will be able to go directly from here to here in your head. And if you can, that's fine. You don't have to show me all of the steps. Okay? All right, now I am going to, just like I did above, because I'm dealing with subtraction here, take the extra step of writing this as a single rational expression. And I'm going to have 10m minus 1 minus 8 minus 2m. And then this negative sign has to be distributed into both terms in the second bracket. Okay, so let's see what we're going to get. Okay, we have 10m minus 1 minus 8m, and then minus negative 2m is plus 2m over 4m minus 3. And that simplifies in the numerator to 12m. Oh, wait, sorry. I made a mistake. This is not 8m, it's just minus 8. There we go. That's better. Okay, so that simplifies to 12m minus 9 over 4m minus 3. Okay, now at this stage, you have to check to see if you can simplify further, because once you add or subtract these things, sometimes you will actually get something in the numerator that's factorable, and it may cancel with one of the factors in the denominator. Okay, here we have a greatest common factor in the numerator of 3. And when I factor that out, I'm left with 4m minus 3. And that is the exact same factor as the factor in the denominator. So now, because I've already stated my non-permissible, I can cancel that. And this entire rational expression, when I subtract, simplifies to 3. Okay? So that is that one. All right, now let's try another one. Here we are adding and subtracting. So let's take a look at what that will look like. Again, we have the exact same denominator for all three rational expressions, okay? Now, in this first one, the order of the terms, or the order of the factors, I should say, not terms, is reversed. But that's okay, because with multiplication, order doesn't matter, right? 3 times 5 is the same as 5 times 3. So it doesn't matter that the order of these binomials is switched, okay? Order doesn't matter. Okay, so I can just go ahead and write this as a single rational expression, and that's going to give me, in the denominator, I will have x minus 3 times x plus 1, and in the numerator, I will have, let's see, 2x squared plus x plus 3 minus 6x, and then minus 8. Now, I didn't take the extra step here because this was just a monomial that I was subtracting, so I don't have to distribute anything. What I didn't do yet was my non-permissibles, so I'll do that right now. Here, x cannot equal 3 and negative 1. Okay, now I can simplify the numerator, and that's going to give me 2x squared minus 5x plus 5, or sorry, minus 5, right? Minus 5 over x minus 3 times x plus 1. Okay, now you should check to see if this is factorable. You could use guess and test or decomposition because this is in the numerator a trinomial of the form ax squared plus bx plus c. Now, if we check, though, we'd be looking for two numbers that multiply to negative 10, right? 2 times negative 5, and add to negative 5, okay? Now, those two numbers don't exist because the only things that multiply to negative 10 are negative 1 and 10, or positive 1 and negative 10, or negative 2 and 5, and 2 and negative 5. Okay, none of those add to negative 5. So what that means is that this is not factorable. And our rational expression is fully simplified. Okay, so we are done. All right. Now, that's what we need to do when we have a common denominator. Let's talk about what happens when we don't have a common denominator. Okay, so here's an example. 2x plus 1 over 5x plus 3x over 2y. Now, if you look at the factors in the denominator, I've got a 5 times an x times a 2 times a y. Those are all completely broken down and factored. Okay, I can't break them down any further. On top of that, there is nothing shared between the 5x and the 2y. Everything there is different. Okay, there's no overlap between any of those factors. So what we have here is a situation like the one where we were doing 3/5 over 1/3 plus 1/3, right? And the LCD was 15. It was 3 times 5. Same sort of thing here. When there are no shared factors in the denominator, the LCD is going to be the one times the other. 2y, okay? And that's because they don't have any common factors, okay? While you're doing your LCD, good time to do the non-permissibles, because this is essentially what your denominator is going to be. So here x cannot equal 0 and y cannot equal 0. Okay, now how do we achieve that LCD? Well, I start out with 2x plus 1 over 5x, okay, and the factor that's missing from this first rational expression in the denominator is 2y, okay? So what I need to do is multiply this by 2y in the denominator, but I also need to do that in the numerator as well, because otherwise I'm changing the value of that rational expression. If I multiply it by 2y over 2y, essentially all I'm doing is multiplying it by 1. Okay? Now, for the other rational expression, this was 3x over 2y. And the factor that's missing from the LCD in this denominator is 5x. So I'm going to multiply this guy by 5x over 5x. Okay? And now what my LCD will be is 5x times 2y is 10xy. So all together, this is going to simplify as something over 10xy. Okay, now what that something is, well, we can distribute here, right? We can simplify. Here we're going to multiply 2x times 2y. So that's going to give me 4xy plus 1 times 2y, so plus 4y. And then plus 5x times 3x is 15x squared. And this is how I add these two rational expressions. Essentially what I need to do is multiply each rational expression by a version of one that is the missing factors of the LCD over the missing factor of the LCD from each rational expression. Okay? All right, so let's try a couple more. Here's another one. 3 over m plus 2 over m plus 1. Okay, well, everything's factored here. Okay, here this factor is m, this is m plus 1. These two things are factored and they are not identical. There is no overlap between m and m plus 1. People really struggle with this because they think that there is overlap of m. But remember, it has to be in the form of multiplication, not addition. If you actually plug numbers in for m, think of if m is 5, m plus 1 would be 6. You can't say that the LCD is 6 because it's 5 plus 1, right? It's actually 5 times 6 or 30. So the LCD here is in fact m times m plus 1. Okay, and that is because these two denominators are factored and the factors are not identical. Okay, so while we have the LCD up there, let's get our non-permissibles. M cannot equal 0 or -1. Okay, and now we can take steps to multiply each rational expression by the factors that are missing from each, factors missing in the LCD from each denominator. Okay, so in this first one, what I'm missing is the factor of m plus 1. So I need to multiply this by m plus 1 over m plus 1. Okay, and then in the second one, 2 over m plus 1, the factor that's missing is m. So I'm going to multiply this by m over m. Okay, now I can write this as a single rational expression because it's got a common denominator. Okay, so here we go. And my common denominator is m times m plus 1. And I can sort of expand the numerators a little bit, right? So 3 times m is 3m. 3 times 1 is plus 3. And then plus 2m. Okay, so all together, this is going to become 5m plus 3 over m times m plus 1. Okay. All right. Let's try this one. Now, this is our first example where we actually have to do a bit of factoring because our denominators are not factored yet. So let's take that step first. Okay. Looks like in each of these denominators we can factor out an LCD. So in the first one, the LCD is 2. 2 times x minus 5. And in the second one, it's going to be 4 over, there's an LCD of 3. And I'm left with x minus 5. Okay, now when I am writing out my least common denominator, I have to have at least the factors of the first denominator in there, which is 2 times x minus 5. Okay, now when I move on to my second denominator, I can look at the factors there and say, okay, I've got a 3 and an x minus 5. Do I have any of those covered already? And the answer is yes. I already have the x minus 5 in my LCD, so I don't need to put it in again. All I need to add in is the 3. Okay, so this is my LCD. And in fact, if you put factors in, if you repeat factors that you don't need to repeat, you're going to make things more complicated than they need to be. Much more complicated than they need to be. So this is your LCD. Okay, what you're going to have if you put in too many factors is a common denominator, but not a least common denominator. And that's going to result in having to do a lot of reducing at the end, which is sometimes not a very fun process. Okay, so try and take the time to make sure that you do in fact have the least common denominator. All right, now the only non-permissible here is that x cannot equal 5. Okay, all right, now let's see what's missing. From the first rational expression, it looks like the only factor that's missing is the 3, because I've got 2 times x minus 5. So all that's missing is 3 over 3. And from the second one, it looks like all that's missing is the 2. So I can multiply this by 2 over 2. Okay, and let's see what happens. Now I'm going to have a single rational expression. My denominator will be 3 times 2 is 6. So I can now write this as 6 times x minus 5. In my numerator, I'm going to have 3 times 5 is 15, minus 4 times 2 is 8. So that gives me 7 over 6 times x minus 5. Just hold on a second. Pardon the interruption, folks. Toby, sweetie, would you mind going to another room for a few minutes?
I really need your iPad.
I'm busy with my iPad right now. Okay. I think I'm just going to give me a moment to just lock the door. And I'll be right with you in a second. We're going to start the next example. Okay. And I'm back. Sorry about that. Okay, the challenges of working from home. All right, so let's do a couple more. Here we've got 4 over p squared minus 1 plus 3 over p plus 1. All right, so again, we got a factor, and there is something that can be factored here. It is the p squared minus 1. That's a difference of squares. So we're going to start out by doing that. Okay, that is 4 over p plus 1 times p minus 1 plus 3 over p plus 1. Okay, now LCD. I have to have everything in at least the first denominator, so I'm going to stick that in. It's got to be at least p plus 1 times p minus 1. Okay, now I'm going to go check my second denominator. That has a factor of p plus 1. And I'm going to ask myself, do I already have that factor in my LCD? And the answer is yes. So I don't need to put it in again. It's already covered. Okay, this is my LCD, p plus 1 times p minus 1. Okay, so my non-permissible values here are plus and minus 1. So you could write that as negative 1 comma 1, or you could write it this way. Okay. All right, now in terms of achieving that least common denominator, well, my first rational expression already has that least common denominator. So I don't need to worry about that. I only need to worry about the second one. And the factor that's missing from this denominator is the p minus 1. So I'm going to multiply that by p minus 1 over p minus 1. Okay, and now I can just simplify. So now I have single rational expression because my denominators are the same, so I can add or subtract the numerators. So this is going to give me 4 plus. Now I could distribute here if you want. You can do this in 2 steps or 1. And I'll tell you what I do. I'm not super consistent. With addition, I tend to do it in 1. With subtraction, I tend to do it in 2. And that's just because with subtraction, a lot of people make mistakes with forgetting to distribute the negative sign into both terms inside that second bracket. Okay, so perhaps try following that lead so that you too don't make the careless errors that I often tend to make. Okay, all right. So all together, what do we have when we simplify? We've got 3p plus 1 over p plus 1 times p minus 1. Okay. All right. Let's see. Do we have more? I think we have one more page to do. Whoops. Yeah, a couple more. All right. So here we have more factoring to do. And we've got subtraction. Oh, this is going to be a fun one. Okay, let's do it. Let's do it. All right, factoring first. So for our first denominator, whoops, there we go. Fix that. For our first denominator, I know what I have to put the pen on. There we go. Okay, eventually I'll get the hang of this. For the first denominator, we're looking for two numbers that multiply to -6 and add to 1, because the coefficient of x is 1. So those numbers are x plus 3 and x minus 2. And then for our second one, we're looking for two numbers that multiply to 3 and add to 4. And that is x plus 3 and x plus 1. Okay, you know what? I am actually going to erase this because I forgot that what I really like to do when I'm writing these out is spread it out a little bit, because I know that I am going to have to multiply this by something over something, right? The factors that are missing from the LCD. So I'm going to spread this out a little bit. Give myself a little bit more space. There we go. That's a little better. All right. Better. Okay. factored. Okay, let's work on the LCD. And again, I'm going to do the LCD now. You could do the non-permissibles first if you want to. Okay, so the LCD has to have at least the factors from my first denominator. That's x plus 3 times x plus 2. No, minus 2. Minus 2. Thank goodness for the eraser. There we go. Okay, and now I'm going to move on to my second one. This has two factors. It's got x plus 3 and x plus 1. Now, I already have the factor of x plus 3 in my LCD. I don't need to put that in again. So all I need to add in is this factor of x plus 1. Okay, that is my LCD. From there, I can write out my non-permissibles. Okay, so here, x cannot equal -3, 2, and -1. Okay, so what is missing from each rational expression in the denominators? From the first one, I'm missing the x plus 1. So I need to multiply this by x plus 1 over x plus 1. And in the second one, what's missing is the x minus 2. So I'm going to multiply this by x minus 2 over x minus 2. Okay, and I have quite a bit of simplification to do now because I've got to distribute in the numerators. I've got to multiply a binomial times a binomial. Okay, and then I've got to simplify by collecting like terms. So let's do that. Denominator. The denominator is these three binomials multiplied together. And you can leave these in factored form. Please do, actually. Okay. This first numerator, I'm going to have x times x, x squared, plus x times 1, plus x. Minus 1 times x is minus x. And then minus 1 times 1, minus 1. Minus. Now here, put this in brackets because we're subtracting all of the second numerator. Okay? X times x, x squared. X times -2 minus 2x. -2 times x minus 2x. And then -2 times -2 plus 4. Okay, so that becomes, this first guy is x squared minus 1. And in fact, we could have predicted this because x minus 1 times x plus 1 is a difference of squares. Whoops, there we go. Sorry about that. Minus, this is, if I simplify it a little bit, x squared minus 4x plus 4. So if I distribute that in, I'm going to get x squared, there we go, sorry, minus -4x is plus 4x, and then minus positive 4 is minus 4 over x plus 3 times x minus 2 times x plus 1. Okay, simplify everything, and we are going to have, let's see, well, x squared minus x squared is 0. So in the numerator, I have 4x, and then -4 minus 1 is minus 5 over x plus 3 times x minus 2 times x plus 1. Okay. So that was that guy. Lots of steps, but hopefully each individual step isn't too cumbersome. Okay. And now we have this guy. And this is called a complex, well, I guess you'd call it a complex rational expression. A fraction within a fraction is called a complex fraction. So we can call this a complex rational expression if you want. And there's a couple of ways that we could approach this one. So I'm going to show you two ways of doing it. Okay. One of them, which I like to do the best, is to see, okay, I really don't like this denominator of y. So what I'm going to do is multiply, because I'm allowed to multiply this whole rational expression by 1, okay? As long as I realize that y is not allowed to equal 0, because y right now is in the denominator. So I've got to say that y can't equal 0. And once I do that, I can multiply the whole thing by y over y. Okay, now if I do that, I distribute this in, and I'm going to get 2y, and then minus 4 over y times y. The y's will cancel, so that'll become minus 4 over y times y is y squared, and then y times 4 over y is minus 4. Okay, that's a lot nicer to deal with. However, you have to make sure that you add in this non-permissible, because when we multiply by y over y, we're canceling that denominator, and that denominator of y is in the original rational expression, so it is a non-permissible. Okay? Now, that is one thing you can do. And we'll deal with this in a second. The other thing that you can do is get a common denominator within the numerator and the denominator. Okay, so if you look at 2, this is currently 2 over 1 minus 4 over y, okay, over y over 1 minus 4 over y. Okay, well, the LCD between y and 1 is y. So I got to multiply this by y over y. And I got to multiply this by y over y to achieve an LCD here and here and here and here. And that's going to give me 2y minus 4 over y over y squared minus 4 over y. Okay, now what this is its division of rational expressions. And we did that yesterday. So we know how to deal with that. This is 2y minus 4 over y, and then we multiply by the reciprocal of this y squared minus 4 over y, which is y over y squared minus 4. Okay, so these cancel as long as, again, you state this non-permissible. And so we end up in the same place of 2y minus 4 over y squared minus 4. Okay, so we still end up here. Okay, if you multiply by y over y initially, it's really slick and it happens really quickly, and there is a less chance for careless error. A lot of people don't think to do that though. So if you see that, it's basically just a matter of experience and exposure to this type of problem. The more you see it, the more you'll start to realize, oh, I can do this sort of thing in this question. Okay, so it's practice, practice, practice. All right, now let's talk about what we have to do here, because there's still work to be done. We have to factor this. And the numerator and the denominator can both factor. So in the numerator, whoops, that has a GCF of 2. And in the denominator, I have a difference of squares. Okay, so from the factored denominator, now I have two more non-permissibles. So I've got -2 and 2 as well. Okay, and once you state those two non-permissibles, you can go ahead and cancel that common factor of y minus 2. And so all together, this simplifies to 2 over y plus 2. And there you have it. So that's all for today. This was a rather long lesson, and it's a big topic and it requires lots of practice. So you will have a lot of class time tomorrow to practice this, but it is very important that you practice it.